So exciting.
Okay, okay, I will. I don't think
I'm going to
so.
mute all.
Okay, all right.
Well, good evening, everybody. I'd like to welcome you to the Muddy Run Virtual Open House. My name is Ted Williams. I'm with the Rittenhouse Astronomical Society, and we'd like to welcome you to a conjunction report of sorts. I'm sorry to say, we're snowed out here on the East Coast. We're also cloud covered, quite snugly in. In fact, they're expecting some rain to come in this evening, so we're not at the observatory. We couldn't ship the ice away to get in there at this time, so we're actually doing this one as a kind of a report for people who are interested in what's been going on right here. I want to share a quick screen with you so you guys know who we are. We're the Rittenhouse Astronomical Society, and if you guys like what you see, you can always become a member right here. There's our donation button there also, and that's what helps keep us going, especially during the time of this crisis that we're actually going through. Okay, so what I'd like to do is we're going to have a couple segments for you, a little bit of an explanation for you. I have a Mistress of the Universe, Denise Vecca, with us, and you probably know that she does a bit of a planet report for us, and she's also going to do a little bit about the winter solstice, which we're all enjoying. I also have Al Ryan in the background here. He's our observatory director. Lou's going to take part today because when we get to the end of our short presentations, we're going to have him do a little bit of a stream and do some stuff live. And we also have one of our dome operators and astronomers, Larry Hubble, with us also in the background. So I'd like to welcome our crew along with this one. And what I'd like to do is turn it over to Denise Vecca first to start us off with a little bit of a planet report. Good evening, Denise. It's good to see you. And I see you're out there in front of a snowy observatory, or a
Well,
good picture?
yeah, I wish I was out at the observatory, but I'm home, a virtual background here, but thought I'd put it on there for a little festiveness. Well, hello, everybody. Welcome to our virtual open house here for December, and happy winter solstice. I'm going to share my screen and we'll get started with our planet report. So I'm going to start with Keynote. Hopefully, everybody can see our first slide here. So basically, just kind of tells us what we're doing. We're going to celebrate not only the winter solstice, but the great conjunction of Jupiter and Saturn. So let's get started. I took this picture from Astronomy Picture of the Day, and I thought it was really cool because it actually showed the position of the sun at the same place on Earth throughout the year. And as we can see, it's got that snake-like pattern because it doesn't always set in the same place. Everybody thinks the sun sets in the west, and it really only sets directly in the west on the equinox, and that's the first day of fall and the first day of spring. But on the winter, the sun is very far south, so it sets southwest. So we have a very low sunset, and that's because the angle of the Earth is tilted. We're not straight up and down out in outer space. The Earth is tilted 23 and a half degrees. So that makes the angle of the sun change throughout the year. In the summertime, the angle of the sun gets very high, as you can see in this first images of the sun, and it stays up very long. So we get a nice warm Earth. It gets lots of bathed in sunlight from that planet. But in the wintertime, the angle of the sun is very low, so the Earth stays cold. Now, you could go out and take a picture of the sun a couple of times a month throughout the year at the same location, and you will get a picture like this, which is called the analemma. I love this image. I think I would even get it as a tattoo. I think it's really cool. It shows the position of the sun during the equinoxes and at the winter solstice when the sun is as low as it gets in the sky, and the summer solstice when the sun is as high as it gets in the sky. And yes, they have solstices and equinoxes and different seasons on other planets. In fact, here is the analemma on planet Mars, which is cool, but notice it's more eggy shape or flying saucer shape. Doesn't have as much of a tilt. So yes, there are seasons on Mars, but they're not as drastic as the seasons here on planet Earth. So that's something you can do if you're into taking pictures. Just go out to the same place once or twice a month, take a picture of the sun, and get the analemma. Now, as I said before, the Earth is not straight up and down. We are tilted. And that means we are either pointing towards the sun or pointing away from the sun. A lot of people think that we're closer to the sun in the summertime, but actually we're about 1 million miles further from the sun in the summer. In the wintertime is when we are closest, around January 2nd. And what happens is in the winter, the North America and where we live on planet Earth is pointing away from the sun. So we get less sunlight and the Earth stays colder, even though we're 1 million miles closer to the sun in the winter. Always a fun fact, and it could, win you a video game or a Trivial Pursuit. You never know. So, fun fact to remember: we're closer to the sun in the winter. Now, the reason for the seasons is because of that tilt, and a year takes 365 and a quarter days. That's how long it takes us to rotate around the sun. Now, all the planets do this, and this is what's leading up into the conjunction. Now, Ted is going to talk more about this, but I wanted you to pay attention to Jupiter and Saturn here and the Earth. Now, it takes about 29 years or so, I think, for Saturn to go around the sun, and only 12 for Jupiter. So eventually, Jupiter is going to catch up to Saturn. And when we look at them from planet Earth, they're going to look close to each other in the sky. So look right here. There they are. They're catching up. And there we are on the opposite side looking at the conjunction. So they don't really get close to each other. It's just an optical illusion as we see it from planet Earth. Now, they've been getting closer over the past few months, and we astronomers have been watching this. And it's not just today. You're going to be able to see them close tomorrow because, unfortunately, we got some clouds, and they're going to get further apart, but they're also going to get lower on the horizon, so they're going to get harder to see. So try and get out the next night. It's clear. Tomorrow might be a good night to get out to see the conjunction of Jupiter and Saturn. So I saw this great graphic that shows how far they were apart back in October, where they're going to be, and where they are today behind the clouds as usual. But I'm sure somewhere around the world they have a live stream, and hopefully we're going to be able to patch into that and show you the conjunction of those planets. So just a couple of pictures. This was taken up in the Pocono area. I'm sorry it's not the best image, but we have Saturn and Jupiter. But here's a better one taken by one of our astronomers and our astrophotographer, Larry Hubble. You can actually see a little bit of the rings of Saturn and the moons of Jupiter, and this is in one view. So the planets are getting close enough that if you have binoculars or a telescope and it's clear tomorrow, or it's clear where you live tonight, bust them out and check out those two planets, biggest planets in our solar system, in one field of view in an eyepiece. Of course, you can get great pictures like this. I would imagine somebody superimposed these two pictures together on the internet, but maybe some telescopes can resolve them into this. I don't know. I think you need a pretty good telescope, but this is the image that you might get to your eye, Saturn with its rings and Jupiter with its Galilean moons. So real quick, I'm going to show you where those planets are going to be. So let's get rid of my keynote and open Safari, and I think I have it set up to right now. Yep, 5:08 p.m. And as you can see, Jupiter and Saturn are really low on the horizon. I have it set up for meteor crater, so there's no trees or anything like that. And little Pluto's there. Of course, you need a little bit of a bigger telescope to see Pluto, so don't expect to go out in your backyard and see that. But there are Jupiter and Saturn very close together, looking like one star. Now, a lot of people have been calling this the Christmas star. I don't know about that, and I'm old, but I'm not that old. 2,000 years ago, I'm not sure what the Magi saw, but some people suspect it was a conjunction between Jupiter and the planet Venus, two of the brightest planets in the sky. So that would have been something amazing to see. Now, between Jupiter and Saturn, between Jupiter and Saturn and Mars, we have the moon. So if you look and you find the moon, to the right or to the southwest will be Jupiter and Saturn, and to the southeast will be the planet Mars. It will not be as bright, but it's still very beautiful, very red, and stars twinkle and planets don't. So you don't have to worry about planets twinkling. So if you see a steady light, just like the moon, it's reflecting sunlight, so it doesn't twinkle. Planets reflect light as well. I'm going to move time forward because not just those planets, but Venus is up in the morning. But I also wanted to show you something. We can see these lines of red. They're called asterisms. And here's a very familiar one directly overhead right now, the Great Square of Pegasus. But if we move time forward, we come to something called the winter circle. And the winter circle is probably one of the most easily and recognizable asterisms in the sky, because the winter sky has some of the brightest stars, and they all center around that hunter Orion. Now, I'm going to move in just a little bit. And if we see Orion's belt, bing, bang, boom, the names are Alnitak, Alnilem, and Mintaka, but don't worry about that. You can just call them Bing Bang Boom. Draw an imaginary line up from those stars, and you run right into the angry eye of Taurus the Bull. It has a nice orangey color, which means it's sort of an older, colder star. And then the Pleiades, or the Seven Sisters, are right up from that, a beautiful little star cluster. If you use a belt, but this time you go down, you reach the brightest star in the night sky, a star called Sirius. I'm serious. It's the brightest star in the night sky, not the North Star. Sirius is very close. It's only 8.5 light years away. So if you could travel at the speed of light, which is what, 12 million miles a minute, it would only take you 8.5 years to get there. So space is big, but that star's like right around the corner. So it looks really bright in our sky. A lot of people think it's a UFO because, once again, stars twinkle, and Sirius is very low on the horizon where there's thick atmosphere, lots of pollution, and it makes that star scintillate and twinkle very much. So Sirius, a very beautiful star, the brightest in our sky. Now, up from Orion's belt, we have Betelgeuse, the cold old red star. Last year, it was very dim. It kind of sneezed and blew some dust out and it was blocking it, but that dust has cleared. And Betelgeuse is one of the prettiest red stars out there that you can see tonight. Right across from that is Procyon in the Little Dog. So that star is also very close, so it looks very bright. And right above that, the two stars are the Gemini twins. You might have heard that when we were talking about the Geminid meteor showers. And my favorite star in the sky, a beautiful star like our sun, Capella. And that's a great place to check out with binoculars. There's a lot of beautiful little star clusters up there in that constellation of Auriga, the charioteer. He was sort of like a race car driver of the chariot circuit and always won. So they made him carry a goat under his arm and her 3 kids. And he raced basically one hand and won, and everybody was so amazed that they placed him at the top of the sky of the winter circle. So during the winter months, Capella is just about right overhead. So that's up by 8:30. You can see the whole winter circle, and stay up a little bit later. You can start seeing the stars of spring. The Big Dipper's getting higher. But if you look early in the morning, right before the sun, you can actually get a glimpse of the hottest planet, Venus. So hot that you could cook a pizza there in like 10 seconds. Of course, get it to go, because there's no air to breathe on Venus. You would dry clean your lungs. So we all love pizza. I wouldn't mind a pizza in 10 seconds or less, but I don't want to breathe toxic air. So I'm going to get that pizza to go if I'm getting a pizza from Venus. Lots to look at in the sky. Some of the most brilliant stars of the season are up in the winter time, so the stars look very bright. Then we also have that beautiful conjunction, lots of planets, Mars, Venus, Pluto, if you have a nice telescope. Uranus and Neptune are also up there as well. So hopefully you'll get a chance, a clear night, to get outside in your backyard with your family, at least see Jupiter and Venus and those beautiful stars of the winter circle. So enjoy. Happy solstice, happy conjunction, and, Merry Christmas. And thanks for listening, everybody.
Thank you very much, Denise. Hey, if you like what you see, you can always give her a thumbs up. We're watching those Zoom screens for you. Thank you. I want to back up a little bit to the Christmas star, because, boy, I've been seeing this all over in the news once again, too. You need to know it's an awful lot of conjecture. There's not a lot to support what's going on. We do know that if we give some leeway to the birth date of Jesus Christ, we know it was during the time of King Herod's reign. We also know he had made a proclamation to register all children. But if we allow that 7-year time frame, there was something back then that would have caught the Magi. their eye. To understand who the wise men were, they come from a different religion of that area, and they were highly scientific, and they would have been observing the sky constantly. A conjunction wouldn't have been enough. Two planets coming together, a bright star, that would have got their attention. But what really got their attention was a conjunction that was happening between Venus and Jupiter. And because of the alignment of the planets, Venus and Jupiter actually came together and separated, and because of their apparent odd motions, came together 2 more times. So things that would happen in a series of 3 would have caught these people's attention. That would have hurled at some great something. 3 was a way to grab attention. So those 3 conjunctions of Venus and Jupiter coming together, and the reason they thought it was important to them is that conjunction actually happened right near Regulus, the King star, which was Leo was a representation of the Jewish culture of the time too. So it's all conjecture, everybody. There's a presentation playing after this, and Lou might be able to show it where to find it, called Seasons of Light. And it's playing out at Methacton School District concurrently as we're talking right about now. Now, let me clear up this. In fact, one of the members came on just beforehand, and he was talking about, what he sees and the type of reporting that they've done on this. And I think we could call it a grand illusion, but the problem is that's a big term to kind of get everybody to basically pay attention. I want to give you some vocabulary to think about, because apparent is something that we're actually seeing. When we look at the nighttime sky and we see this conjunction, it's an apparent conjunction. And I want to compare that to something that's real, something that is factual, so that's happening. And today, just to get an idea of a little bit of the terminology, we'll call these apparent motions that we see in the sky. And this is what really fools everybody. There's 3 main apparent motions that will fool you. And then there's a real cause that happens. All 3 of these motions are on display tonight when you look up at Jupiter and Saturn coming together. And these vocabulary might help with some of the questions we have. So when I say apparent motion, just think of something that we're observing in the sky. When I say something it has a real cause, this is what's responsible for it. This is what's making it happen. So here's something that really fooled us for thousands of years. We observed that the sun rises and sets along with most of the stars, the moon, and the planets. It does it every night. They rise in the east, stars set in the west, sun does the same thing. It was such a great illusion that most cultures thought that they were the center of the universe. They couldn't imagine the Earth turning. It had seemed such a solid object to them. So to them, they would see this motion, and they thought the whole universe was traveling around us. The real thing that we call this, though, is daily motion. It's an easy way to remember this. And this would answer the question that I had from some people who said, Ted, when you talked about this a couple months ago, it was up in the sky in the south, and now they're way over there in the west. Well, that's because daily motion is carrying them over to the west, and because we're moving around the sun, a second motion, it makes them appear later in the evening sky. All this daily motion is caused by Earth is spinning. So tonight, if you get out there much past 6:30, they're going to set. And that's all because of the Earth turning, Earth's rotation. If I were to give a passage of time to this daily motion, I'd say how long you would actually be able to notice something like this. Well, you can actually see your shadow change in about 5 minutes' time. That's showing you daily motion, like a sundial would. So most people can see the difference within 5 to 15 minutes, that things are slowly moving across the sky. Second thing that's going to fool us all, and this is a picture of what daily motion looks like. There's the North Star right there in the center. A common picture on the internet most people don't understand. I think you're probably looking maybe at a 20-minute exposure, and you're actually seeing a bright star and its trail as it appears to move across the sky. Because the camera's focused on the North Pole, all of these stars here, they don't really rise or set. They tend to just keep moving around that North Pole. Anything that's over here towards the east, that would be rising, and over there towards the west, it would appear to set. So this is all an illusion. It's all caused by this daily motion. So there was something else that got everybody's attention long ago. They noticed that the sun moved from constellation to constellation, and it happened throughout the year. We could call this annual motion because they could see that it happened about once every year. The sun would look like it moves through the constellations. And they could actually see this right at sunset or just before sunrise, looking over at the horizon. You could see the apparent change of the motion. So annual motion is really Earth traveling around the sun. And as it travels around the sun, the sun looks like it moves or shifts in relationship to the stars in the background. How long to see this? Well, an astute observer might be able to see it pretty quickly, but I'd say if you're out there looking around, about 1 week you can see this. This is similar to what Denise was showing you. So here's the Earth right here in the first picture, upper left. There's the sun. And if you look far off in the distance, the sun looks like it's in front of Pisces. Sun's not going to move. Earth's going to do all the motion. So when we're over here, the sun looks like it's now shifted and moved over towards Gemini. That green area that you see right there, that line, that's the path of the ecliptic. So as you can see, the sun does look like it shifts through those different constellations. Again, all because of that annual motion. And here's what we're actually seeing almost tonight too. They noticed a long time ago that 5 stars appeared to wander. Now, everything was rising in the east and west, and setting in the west, but these 5 stars, they would do that nightly, but if you watched for a couple days, they'd slowly start to wander from west over towards east. So we could call this planetary motion. It's an apparent motion. They appear to wander from west to east across our sky. So what's really happening? They're revolving. They're moving around the sun. And as they orbit around the sun, we see them shifting in the constellations in the backdrop right there. What's interesting is planetary motion. Really, I used to say you could see it in about 1 week, but you can tell the difference in 1 day. Just looking at what we've been looking at in the past couple days at this conjunction, it can actually be seen very quickly on a night like tonight. So here's kind of some of the motions all put together. Imagine you're on Earth and you're observing here, and here's Jupiter right about here. Jupiter, from this point in our view, appears very close to that bright star right about there. And as we pass Jupiter in its orbit, let's go back, sorry about that. As we pass Jupiter in its orbit, let's say we get over here, well now Jupiter doesn't appear in the same spot. It actually looks like it went a little bit retrograde, it moved backward, and it looks like it's over by this area of the sky. Look at Mars. The whole effect is accentuated by Mars. Look at this apparent motion here. And this is what really stumped people a long time ago. These planets would look like they were moving along their path. They looked like they would stop, they would back up, and then they'd move forward again. That's what gave rise to the whole idea. They must be godly. There's something going on there. And it led the early scientists to explain an entire convoluted system that included little epicycles that these planets traveled on. So take a look at Earth. Here it is, looking at Mars right here. And from this point of view, Mars appears to be way out there by that bright star. And then over here, when Earth is here, Mars appears to be back over in this area. It appears to have backed up, had a little bit of that retrograde motion right there. So let's do one last thing, and this will help. And Denise did a pretty good job at this one also, but I think I can do this way. I'm going to show you kind of a virtual 3D model here of what's going on tonight, and I'm going to use a piece of software. Come on, let me see. Maybe I'm not allowed to share. Okay, I think I am. And give me just a second. Come on, come on. And, oh, it's working. I see it's going out to you guys also. Okay, I'm using Solar Walk right now. Give it a second. All right, we're so far out, you're seeing the sun right there in the center and the asteroid belt around the outside. As I start to move in a little bit, there's the inner asteroid belt, and there's Jupiter and Saturn on the upper left, and here's Earth right down here. So here's what's interesting. When they say that these planets are really close together, again, it's all apparent, because if you look, they're out there in their orbits. They're no closer, respectively, to the sun than they normally would be. Yes, they are closer to each other where their orbit is, but they're not as they appear in the sky. They're not touching each other. And the only reason I like this is because it actually gives you a good, like a three-dimensional model. So if I move in on this, and let's say we go to Earth, and let's say I look from the dark side. So you have to imagine you're standing on the other side of the Earth, and you're looking over there at the sun. So as the Earth turns, the sun would set. The sun would rise, but before it would rise, there's Venus. Let me line it up so it looks like this. So here's the morning sky. We're just coming around to the daytime side, and when you see the sun come up over the horizon, right about there, well, there's Venus in the morning sky. Okay, so the sun crosses our sky, and at the end of the day, when it sets, well, look over there. There's Jupiter and Saturn. And in this software, they're blown up so big, they look like they're on top of each other. Again, a grand illusion. What you're just seeing is the two of them appearing to be together. So it's a little bit of a three-dimensional model to give you an idea of what's going on out there in space. Let's stop that for a second, and I'll bring it back to our main screen. And I'd like to introduce Lou to a lot of you because, hold on, I got it. Lou's been with us about 2 years, and he got interested in helping us out with the conjunction. And Lou, did we find any site that does have something live for us?
Yeah, we have something. It's hold on, let me share my screen.
And do I switch host to you, or you?
I'm already host. I got
Okay.
you. Share screen, and then we want to do this one. So what we have is this stream right now. This is coming from a site called Cosmos Sapiens. They're just an educational site, and right now this is just their stream that they've been putting out for most of the afternoon. So I don't know, Ted, if you want to talk about it a little bit, just what we're seeing, the image that we're seeing.
This is actually pretty good, everybody. One of the hardest things to do when they're working with live stuff is to get both the moons and the view of the planets to become visible. You can barely see the rings. I can see the rings easily on Saturn over here. I just think I'm seeing the belt on Jupiter itself also. This is pretty good. That's a very, very good actually for a video. And the reason you just can't see Jupiter's moons is you have to cut back the gain so much on the camera and cut back the exposure time to get both Saturn and Jupiter, fairly bright objects, in the cosmos for us. You have to cut the camera back to its minimal exposure time and gain, and you lose the view of the moons. So if I was live and I'd be playing around with this, I'd start to change the gain right now and see if I could bring the moons visible to you also. This is a good one though, Lou. Thank you. Any others out there?
As far as actual live streams, right now, this is the best one that I've found.
Okay.
Denise told me that Lowell Observatory will be streaming in about an hour and a half. Their stream is starting at 7 p.m. You can see it right here.
It's because they're on the West Coast, right? They're waiting for darkness?
I assume so. But they'll be going up in about 7 p.m. But for right now, this is what we have. But this is, like, I believe, a live view.
So here's the one thing I want to put out to everybody. You've all had your attention caught by all the media saying, okay, here's the grand conjunction. Remember, if you're clouded out tonight, go out tomorrow night and take a look. You'll see it's amazing these past couple nights because once they get close together, again, take your arm, put it out to arm's length. Just 2 nights ago, I couldn't get my pinky fingernail in between the two of them. And you can actually see it, changing every night by night. So it's still a good opportunity. They will continue to get lower and lower to the horizon, so you're going to have a clearer view. But for the next week or so, you should be able to get out there. It's kind of a pet peeve I've picked up because our media always focuses on the moment, the exact moment when they're the closest. And yet, if you've been following us here at Muddy Run, this is a very unique moment for me because this is a culmination of something we started last summer. We were all live, sitting there for the Sky and Star Festival. We looked at Jupiter and Saturn. They were 3 fists and 3 fingers apart. I had the whole audience do it with me. And I told them to wait for another year and watch them come together. So it's good to align yourself with an astronomy club or a group like Muddy Run because I'll be honest with you, there's a lot more to see, and you don't have to just wait for that one intense moment, when it's supposedly the best and most likely going to be clouded or raining out. This is something you could have been enjoying for quite some time. So the only thing that's going to happen now is they're going to look like they fall behind the sun. And in another month or two, you might want to start looking in the very early morning sky because you'll see both Jupiter and Saturn. And then it'll be a morning treat for a while. Use your hands again and watch them start to move further away. I think it's the coolest thing, everybody, to see everything, the universe in motion around you. And that's why I wanted to keep this conjunction report on going tonight, just to clear up a little bit and help people understand. Denise, you did a great job. I always appreciate you doing the work that you do with us. I really like how your star talks. I feel like I'm in the planetarium when I'm listening to you, so I just really enjoy that also. Al, if you wanted to say anything for the end, we'll probably sign off right about now. Al's our observatory director. Okay, so I hope you and Larry, I wanted to thank you for submitting your picture for us. Denise, I don't know if you saw it. Denise used it in the very beginning. Thank you for doing that for us. Appreciate it. Larry, before we go, if you try to unmute yourself, do you want to tell us what picture you're working on now at the observatory? Give him a second. I just asked him to unmute. He should get it. Al, you have to unmute yourself. I'm sorry, Larry, you have to unmute yourself.
Okay, am I unmuted?
Yes, I hear you now.
The
Go
photo
ahead.
that was shown, which I appreciate, was not my photo. I don't know what happened there, but if you want me to share it, I could.
Oh, okay. Go ahead.
Okay, because this is the one that I submitted. Now I'm going to try to share my screen.
Give me a second. Give me a second. I have to give you that approval. I will. Hold on. Let me find you. Larry Hubble. Oh,
Sorry, Larry. I thought one of your videos or your picture was in there. I had 3.
That's fine. I didn't see it. I might have been mistaken.
Try it now, Larry. You should
Are
be
we
able to
ready?
share.
Can you?
Yep.
Okay. Wait a minute. Is this my screen? Okay.
Yep.
Can you hear me?
Yep. We're on your
Okay.
desktop.
This is the photo I shot. This was last night. It was at 6:16 Eastern Standard Time. I say it's almost the conjunction, but the image, if I blow it up, that's 500 millimeter lens. The moons are superimposed. Is that right?
Yeah.
They're taken at the same time, but different exposures. So, and then when I blow it up,
you put the picture together to get the.
Then I put it over here a little bit more blown up, and I picked up a little detail on Jupiter, and the moons are superimposed. But that's the photo I got last night, and I was just okay. How do I unshare here?
I'm sorry, Larry. That was not the picture I showed.
That is.
Where it got by my braids, probably.
Yeah, that's the one I got last night. How do I unshare? How do I do that?
Thank you.
I'm trying to also withdraw.
Okay.
Let's try this. I think I took it away from you. I'm not sure.
That's the recent picture of my background there.
Great.
Larry, do you have any of the subs you've been working on with the Ursa Major galaxies, M81, M82?
I haven't gotten back up there with the snow, and everything. I haven't gotten back up there. Last time I was popsicle. It was so cold. So
yeah, but I thought you had some preliminary subs that.
Oh, I do. I have some of the ones we showed at the meeting. You want to see those?
Yeah, I don't recall.
Sure.
Okay, show my screen.
Oh, I'm sorry.
Because I don't know what to do there.
I know. What I had to do was I took the co-host away. Give me a second. You should have it now.
Okay, we on?
Yep.
This
Not
is
yet.
just, I think this is just this is
Not
only
yet.
one. This is how sensitive the S-Big camera is at MRO. It's amazing.
Larry,
That's
try
just one
sharing.
shot.
Larry, try sharing the screen again. We're
Okay.
seeing you.
Okay, so you don't have me?
Nope.
Okay, hold on. You have my screen now?
No.
Oh,
Nope.
nope, yep,
Nope.
yep,
Nope.
nope. I don't know what to do. Oh, do I have to hit share screen?
Yeah.
Yes, sir.
Okay, I'm sorry, hold on. Okay, that should be my screen.
We
I
have
do not know this software.
It's okay.
Anyway,
We're all
Al and Al's always there to help. We got this one image, 10 minutes
Wow.
of M81. That's monochrome. I still have the red, green, and blue to
Wow.
add to this image. Once again, one shot, 10 minutes. Amazing.
That's
Amazing.
one. That was one shot, 10 minutes.
1 minute. This is an hour and a half stacked of the M81 galaxy. So we have to add color in. But it's been so cold I haven't gotten up there.
They're beautiful to start with.
82 in red. I'm struggling with this one, but I still have to add more. But you can see the red filaments here within this galaxy. All this is the red burst out of the center. I'm hoping that'll come out better. So that's the preliminary of M81, M82, and just the other day I finished.
Larry, is this a new background?
Yes, this background, I'm just trying to show you that. I just did this one.
I thought you said you didn't like it. It looks better.
I think it looks
I worked
great.
on it. I worked on it for like 10 hours. Okay, so this is my background. This is the newest, but I lost it. I just lost it. I don't know where.
Oh, wow. Share
I
that
don't know
one
where
with
the-
us, Larry.
What?
That's a beautiful shot. Share that one with us. That's a
I'm
beautiful
trying.
shot.
Okay, here we go. I found it. Okay, now this one had bad seeing over the 3 hours. I shot it for 3.5 hours. The buffering from the camera to the chip took away about a half hour, which was really good. So this is about 3 hours. Now, it stacks them, but as this software stacks them, it creates the rotation. If I did it old school and opened it for 3 hours, the foreground would be totally blown out. So with this software, I can include the foreground and the background is as if it was shot for 3 hours because the software stacks it in the motion. So that's the newest one. And like Al said, it was pretty bad. And I went in here. I literally went in and just
I wouldn't
got
say
rid of
pretty
a lot of the
bad.
seeing conditions. Was it?
I thought it was pretty good.
Yeah, it's not bad. I mean, but I was a little bit surprised.
I even see some of the star motion through the trees over here. Look at it. Look at the detail coming down in here.
Yeah, it's pretty cool. I'm okay with it. But it took a lot of work to get all the seeing. There was little spaces in between all these, a lot of spaces. It took me about 5 hours to go in and fill in the spaces in the stars from the stars twinkling too much on a bad scene. Okay, how do I get out of here?
Stop sharing. Or
Stop
I can also
share.
I can
I
take it
got
away.
Hey, I'm getting the hang of this.
There you go.
Okay, thank you.
That's great. Thank you. Thank you.